Well, Pete, let's start with the inner solar system. And Mercury was at greatest western elongation on the 22nd of July, so it was visible in the morning sky. And at the start of August, it starts to head back towards the sun. And so this means the rise time before sunrise is decreasing. So not got long to catch it in the first part of August.
No, that's right. It's also being joined, of course, at the moment by that beacon at the beginning of 2020, which has now slipped into the morning sky, Venus.
Yes.
Venus is a very brilliant planet rising 3 hours before sunrise at the beginning of August. So that's pretty good, really. And through a telescope, Venus appears 43% lit and 27 arc seconds across. Venus is a tricky planet, though, isn't it? It's very difficult to actually get much out of it.
Well, it depends, I guess. I mean, some people who've been using UV imaging in the last elongation, they got some striking details in the clouds. And visually as well, these were some of the most striking cloud formations I'd ever seen with the eye before. So I don't know. I think sometimes Venus can actually be quite dramatic. You just have to catch her at the right time.
It's a very subtle planet, isn't it? That's the issue, I think, with it. But there's a lovely meeting between Venus and an 18% lit waning crescent moon on the morning of the 15th of August. So that should be pretty good.
Yes, and the planet comes to greatest western elongation on the 13th of August, or around about then. And at this time, it appears 50% illuminated. Now, because of the Schroter effect, in actual fact, it will reach dichotomy a bit later. Dichotomy is when the planet appears to be 50% illuminated. The Schroter effect means that the phase is always less than the predicted phase. So when it's in the evening sky, dichotomy is always early, and when it's in the morning sky, it's always later. So if you look out on the 13th of August in the morning, Venus should technically be 50% illuminated, but it probably won't be, probably about 49, 48%.
Okay, so you need to use a reasonable magnification to actually be able to determine the phase, I'm guessing.
Yeah, at least 160 times to see it convincingly. Okay. And this is don't use a filter on it, because if you put a blue filter on, the Schroter effect is really enhanced. So you have to do this with no filter at all.
Okay. Good advice there. Okay, so on the 31st of August, so at the end of the month, Venus rises about 4 hours before sunrise and shines away at magnitude minus 4.1. So that's going to be pretty brilliant. And by that time, the phase will have increased to 59%. And it'll be 19 arc seconds across. So it's beginning to move quite a way away from the Earth. We're going to lose it.
It is. It is. It'll move away and continue to move away from us as time goes on. Moving to the next planet out, this is quite exciting. The planet Mars reaches opposition in the middle of October, and it's now really starting to come good. And I because we don't get opposition to Mars every year, I really enjoy observing Mars.
Well, this is a special opposition, of course, because this is going to be the best one for quite a while, actually. Because it'll be well positioned from the UK and it'll be fairly large through the eyepiece of a telescope. The one in 2018, if I remember correctly, it was 2018, wasn't it?
Yes, it was.
It's every 2.1 years, isn't it, for oppositions of Mars? So the one in 2018 was pretty big. But this one's only going to be a fraction smaller, so that's exciting for us from the UK.
It is. It's more the altitude as well, Pete. Don't forget the one a couple of years ago was really incredibly low down for UK observers. This time it's going to be much higher in the sky, and so we are going to be really well placed to get some great views of Mars over the next coming months.
But we'll get that sort of, or I hope we will, we'll get that sort of Mars fever activities starting as people start to notice this really bright orange beacon in the sky, and that is quite an exciting time when it gets so bright, and it will actually overtake Jupiter in terms of brightness to become the second brightest planet visible to the naked eye in the sky, which is quite incredible as well.
It is quite something, and of course there'll be plenty to see on the disk, providing we don't have a a big dust storm that starts up and obscures all the features. You'll have the bright southern polar cap. It will have shrunk down quite a bit then, because it'll be summertime in the southern hemisphere on Mars, which is the hemisphere tilted towards us. But we'll have some great views of all of the dark albedo features, and it'll be really great visually as well as for imaging.
Okay, so on the 1st of August, Mars will be shining at mag minus 1.1, which is quite bright, and displaying its beautiful salmon pink colour, of course. And through a telescope, it'll be about 14 arc seconds across at the beginning of August, and the disk will appear to be about 86% lit. So it's a gibbous phase it's showing. But there's an exciting opportunity to catch it near a 73% lit waning gibbous moon on the morning of the 9th of August, when it'll be really, really close to Mars. And as the sky begins to brighten on the morning of the 9th, both objects are just 3 degrees apart. And because Mars is so bright, it might be possible to stay with it even during the daylight when the sun has come up, and the separation drops to about a degree around about 11 o'clock BST. So that'd be something to look out for.
There was something interesting to try. Magnitude minus 1.3 is quite bright, so might just catch it during the daytime. If you as the skies begin to brighten, it might still continue to be visible in the telescope.
Well, you can certainly catch Mercury when it's at that brightness during the day.
I have done that. In fact, I had some of my first proper views of Mercury this year with it during the daytime, and it was about that brightness. So I know it can be done.
Okay. Well, at the end of the month, Mars will be shining at magnitude minus 1.8 and present an 18 arc second disk when viewed through the eyepiece of a telescope. Now, 4 arc seconds may not seem like much, but it makes a world of difference when looking at Mars. So that'll be quite exciting. And it's only going to get better, of course.
It is. So plenty to look forward to with Mars. Further out, well, Jupiter's just reached opposition not long ago, but unfortunately incredibly low down here in the UK. It's been low down for a while now, so eventually it will start creeping back up, but we have to get used to it being low for another year or so longer. This means it's going to be affected by the turbulence of the atmosphere, but you still can catch moments of good seeing in the early hours. So I still say it's worth going out and having a look at Jupiter.
Yeah, definitely worth looking at Jupiter. It's a tricky world, really, and actually that low altitude has a major effect on a planet like Jupiter, because Jupiter is full of detail, isn't it, when you look at it through the eyepiece of a telescope?
It is.
It's just all those cloud belts, little sort of tiny blips and dips in them are quite difficult to see when the atmosphere is just mushing everything up. And the same is true for Saturn, of course, because Saturn is quite close to Jupiter at the moment in the sky and equally as low. Yes,
it does mean that all but the best details do get washed out. As you say, there's not quite so many subtle cloud features on Saturn as there are on Jupiter, but Jupiter in particular has a lot of interesting stuff going on in the belts, and that can be really, really hard to see visually when it's this low down. But as I said, you might get lucky and have some moments of good seeing in the early hours of the morning, so that's when it's normally best to try.
Yeah, okay. Well, Jupiter is about magnitude minus 2.5 throughout August, and Saturn, which is to the east of it, is about magnitude plus 0.5. So quite a difference in their appearance. But Saturn should still appear very obvious to the east of Jupiter. And I think one way of telling how good the seeing is with Saturn is to look at the rings, which are quite widely tilted to us at the moment, and see whether you can see the division between the A ring and the B ring, that thin line, or thin gap, which is known as the Cassini division. And if you can spot that, then the seeing is pretty good. But if you can't, then it's fairly typical for the UK at that altitude, I'd guess.
It is, and it's the Cassini division under normal conditions, reasonable seeing would be visible in a 3-inch telescope. But if the seeing is poor, then it can be very, very difficult to see in even larger instruments.
Yeah, okay. Well, heading out to the ice giants, Uranus and Neptune, they're both morning planets at the moment. Uranus reaches its highest point due south in darkness by the end of August. And it's currently on the threshold of naked eye visibility at around magnitude plus 5.7.
Yes. So that's not really going to be possible. Although, in lockdown, I have noticed that the skies have been a lot clearer. Perhaps because we haven't had quite so many aircraft up there. I don't
Makes a
know.
big
Can't
difference, yeah.
I think it has made quite a difference. So who knows? I mean, you've got a really nice dark site from your garden, Pete. You might want to try this and see if you can spot it with the naked eye. The trouble is there is always lots of faint stars around in that area.
Of
So
similar
would,
brightness, that's right.
yeah, it'd be difficult to be absolutely certain that you've seen it.
Yeah, I agree. Okay, well, Neptune, as I say, is a morning planet as well, and that improves in appearance throughout the month, managing to reach its highest point due south in darkness from about the middle of August onwards. It currently shines at mag plus 7.8, and I guess, well, the easiest way to see it is through binoculars, but a small telescope, will show it fairly well as well.
Yeah, as you pick up the colour, it's quite a distinctive bluish disc, so quite unmistakable.
Yeah. Okay, well, let's move on to some of the special events which are occurring in August. So we've got Mars at perihelion on the 3rd of August, a time when the planet is closest to the Sun. So that's going to be the time when Mars is getting its maximum energy from the Sun, and potentially when the dust storms are going to start to appear, I guess.
Yeah, so there's been some predictions from Richard McKim, who runs the BAA Mars section. It's probably not going to be a global encircling storm. This is where you get the whole planet completely hidden from view because of the dust clouds. But we probably will see regional storms that might appear. So always best to watch out for these. They always start life as quite conspicuous orange clouds in specific regions. So if you think you see something like that, keep a track of it, because it could well be a dust storm starting up. So they are quite exciting, and they're very ferocious Martian dust storms. But when they become global, it just hides everything, and Mars becomes sort of a dull orange globe. So let's hope it doesn't do that.
So if you're observing visually, is there a particular filter which picks out the dust storms better than others?
Yes, actually, the Raton 21 orange or the Raton 25A red is quite good. That it enhances the contrast, because the storms have a slight orange tint to them, these orange clouds anyway. If you try one of those filters, that should increase the contrast.
Okay. Oh, well, that's something to look out for then. I just hope they don't spread out too much, because that will cover up some of the detail. Okay, so on the 7th of August, as Jupiter rises, giant Ganymede will be in transit, and Ganymede is located centrally on Jupiter's disk at 2245 BST. The transit ends at 0028 BST on the 8th of August, and Ganymede's shadow will also be in transit from 2330 BST until 0250 BST. So that's something which is always worth looking out for. I love seeing those large moons move in front of Jupiter, accompanied by their shadow.
The shadow of Ganymede in particular is quite striking. Even in really poor seeing, you could still see this enormous black dot on the clouds of Jupiter. So that's a good one to watch for. It won't matter if the seeing's poor.
Okay. And on the 11th is Callisto's shadow, which is transiting Jupiter's disk from 1943 BST until 2355 BST. So that's a good time to actually pick that up.
Yes, and again, quite rare. Callisto we don't seem to get very often the Callisto transit, so this is one to make an effort for, because it's the furthest out of the Galilean satellites, and so the orbital circumstances have to be right in order to catch this.
Okay. So on the 12th of August, of course, we've got a very famous event occurring, which is the peak of the Perseid meteor shower. And that's a shower which has a zenithal hourly rate, typically above 100 meteors per hour, which is the optimum rate you can see under perfect skies, if you can see the entire sky in one go, and everything is absolutely perfect. But in reality, it isn't. You also have to, the zenithal hourly rate is the rate you'd see if the radiant was directly overhead, which it tends not to be, of course. So the number you'll actually see will be a lot less than the quoted zenithal hourly rate, probably in the 30s or so per hour.
Yes, but that's still quite good, though. I mean, 30 an hour would still be quite an active shower. I've had very little luck with the Perseids. I think I've only had about one good Perseid meteor watch in about 15 years. So maybe
Really? Wow.
because it either goes cloudy or it's the moon's been in the way, or when it has been clear and the moon hasn't been there, it's just been a shower which hasn't been particularly active that year. So surely by now, hopefully, this means I'm due for a good Perseid meteor shower. Maybe.
Wouldn't count on it.
No, maybe, maybe not. We'll have to wait and see. Still worth going out and doing.
Well, there will be a moon around in the morning sky, but it's definitely worth going out to look for it. Just place the moon behind something. That's the easiest way to deal with the moon. But it's the nights of if you want to cherry pick the nights, in reality, if you're going to observe a shower properly, you should do it the full range, of course. But if you want to cherry pick the nights, it's the nights of the 11th, 12th, and 12th, 13th of August, which are best for viewing. And typically, it's the best rates are seen after midnight universal time, so after 1 o'clock in the morning BST.
Yes, so that's a good time to go out and try. Hopefully it'll be clear and not wet, and we'll see some meteors.
Okay, well, fingers crossed for that. And it's also worth just one final mention. Towards the end of August, we've got Minor Planet 1 Ceres, which reaches opposition in the constellation of Aquarius at magnitude plus 7.7. So binoculars again for that will get you a view of Ceres.
Good. Okay, well, shall we move out into the night sky proper? August is quite a wonderful time to be out. It's warm, the skies in August are starting to get darker, and there's so much to see, particularly in the Northern Hemisphere with the summer triangle overhead. I think this is one of my favourite times of year to observe, Pete.
Right, okay, yeah, I mean, it's fairly balmy typically in August, so, and the other big benefit, which shouldn't really be a benefit, but it is, especially if you're busy, is the fact the nights are really short. So you don't have to stay up for hours and hours if you need to get some sleep. And yeah, the summer triangle is fantastic. That's an asterism, an unofficial pattern of stars formed from three bright stars. There's Vega, which is the brightest star in the constellation of Lyra, Deneb, the brightest star in the constellation of Cygnus, and Altair, the brightest star in the constellation of Aquila.
Yes, and what is particularly lovely is that the Milky Way, one of the spiral arms of the galaxy, runs down through Cygnus, so in fact through the summer triangle, all the way down to that teapot asterism of Sagittarius the Archer. And from a dark side, it's great, I think, just to get a pair of binoculars and trace down the Milky Way all the way from Cygnus down to Sagittarius, because it really is quite a splendid sight.
The real sadness about it, though, is from the UK, the core of the Milky Way, which is just near the spout of that teapot asterism in Sagittarius, is really low for us. So the brightest part of the Milky Way, which should be the core, is attenuated by the thicker layer of atmosphere low down. So the brightest bit for us in the UK tends to be the bit which runs down through Cygnus. And that's the bit which looks split in two,
yes.
Because there's a dark rift or a dark dust lane that runs along the Milky Way there and appears to split it. And that's called the Cygnus Rift.
Yeah, it's quite an impressive sight, particularly either with very low power binoculars or the naked eye if you've got a dark sky. It really is quite a stunning sight. And it almost gives it, in a real dark sky, a three-dimensional look to that part of the galaxy. I always think it's quite stunning. Well,
the Milky Way flows down through the summer triangle, but you've also got another asterism there, which is what's known as the Northern Cross, and that's the body of Cygnus the Swan. So it's the vertical of the cross is the body plus the neck down to the head, and the arms of the cross form the wing stubs, if you like. It gets quite complicated describing that. But at the bottom of the Northern Cross, the star marking the bottom of that is Albaria, which is that beautiful star, which is a beautiful coloured double star. It's just one of the most glorious things to look at through a telescope.
It is. It's very, very hard to give it, to describe its true majesty just using words. People have to see it. It really is a glorious double star. One of them is turquoise in colour, the other is golden. I often used to think, I mean, I don't know if there are any planets around there, but if there are, sunrise and sunset would be particularly spectacular in that system. It really is quite a fantastic binary star. Probably my favourite in the whole night sky.
Okay, there's a lot of conjecture about whether it is a true binary or just a line of sight effect. I think the thinking at the moment is that they're not actually gravitationally linked together.
No, I don't know what the latest thinking of it is. If they're not, then they're not a true binary. If they're not, as you say, Pete, gravitationally connected, then it's not a true binary system. It's simply line of sight.
The big problem is that they just appear to move very slowly relative to each other. So we haven't had long enough to be able to measure the position of the components to work out whether they are actually in orbit to each other.
No, so something that will require a lot more observation before we're able to tell if Albiro is a genuine binary star.
Yeah, okay. Well, off the northeast shoulder, if you like, of the Swan, so quite close to Deneb, there's a lovely patch of sky, best seen really with very low power binoculars, or even the naked eye if you've got a really dark sky, and that's a region which holds the nebulous form of NGC 7000, the North America Nebula. And that's called the North America Nebula because it looks very similar to the shape of the continent of North America.
Yeah, I've never seen that personally. It's only ever looked like a fuzzy patch to me, but I think that's because I'm not in a massively dark sky. I suspect if I was to look at it from a very dark sky side, I might pick that out. But yeah, it's certainly nice to see. And the northwest vertex of the Summer Triangle, this is marked by the brilliant star, bluish-white star Vega, the brightest of the stars in the Summer Triangle. It's in the constellation of Lyra, which looks like a squash diamond pattern, but there's some interesting stuff in this constellation. In particular, the southernmost two stars, Beta and Gamma Lyrae, we find the remnants of a star that was once like the Sun, but has come to the end of its life, shed its outer atmosphere. This is the Ring Nebula, or M57.
Yeah, that's a glorious deep sky object. It's one of the first I think I looked at with my. I'm going to give it its full size because it's important to give it its full size. It was a 222 millimeter reflecting telescope, and there was a lot of pain went into that telescope because I ground the primary mirror myself, so I want every millimeter of that aperture. But I can remember looking at M57, and it was glorious because as you up the power, especially with a larger aperture, you start to see the central region is darker. So it gives it this, you've got this sort of oval glow and then this central dark region. So it looks like a ghostly smoke ring in space. But seeing the centre star, which is about magnitude 15-ish, that's tricky, isn't it?
It is tricky. The first time I saw M57 was with my 4.5-inch reflector. I was actually quite surprised at how bright it looks. It does seem to have a high surface brightness. But the central star I have seen with the university's telescope. That's a 20-inch telescope. I will try with my 12-inch telescope to see it, but I'm not sure I'll pick it up. Have you caught it with the C14, Pete?
I'm going to have to admit I've never actually looked, and I should do that. But there have been reports of it being seen with smaller telescopes still. And I think one of the issues with it is that to see that central star, you need to have really good seeing.
Yeah.
And if you don't get good seeing, then it just sort of disappears as it gets slightly blurred in appearance. So yeah, that's a bit of a challenge. So I suppose let's wrap it up there and just say go outside and enjoy the August night sky.
Indeed. Thanks, Pete.
Thanks, Paul.